Hello, everyone. My name is Hari, and I'll be a host for this panel about EVM languages. We have 40 minutes. We have four panelists representing four different languages. We'll get started right away. For the audience, I have some time for questions later, so prepare. So let's start right away with three questions back to back. First of all, introduce yourself. Give us a 30-second pitch for your language. And what is your second most favorite EVM language? Starting with Grant.
Yeah. So my name is Grant. I work on Feeling. The pitch for our language, I'll just list off some features and things. First of all, it's implemented in Rust, and the language is similar to Rust. We have a standard library, and therefore we're able to keep a simplified language core. We support enums and pattern matching. We provide a built-in test runner. We have limited generic support, currently. And the analyzer is based on Salsa, and it provides really nice errors. My second favorite, I don't know, it's hard to choose. I'll pick Huff because that's the only different one here.
Nice. Go for it.
Hello, everyone. My name is Z80. I'm from Viper. For those who don't know, Viper is a Pythonic smart contract language for the EVM. It aims to maximize security, make it hard to write insecure code, making it convenient. It strives to have a simple implementation where anyone who knows Python can take a look at the compiler and understand what's going on. And auditability. Sometimes that comes at the expense of having to write a little bit more code, but that code will then be more clear about what's actually going on. We try to not hide things behind complex syntax. And yeah, it looks a lot like Python. So if you know Python, you know most of Viper.
Hey, yeah, I'm Maria. I'm here representing Huff. And I can say Huff is not really, sorry, closer? It's not on. Oh, shit. Hey, yeah, I'm Maria. I'm here representing Huff. And Huff isn't so much of a language, it's more of like a macro assembler. But it kind of, if you think you can beat the compiler, then you should use Huff because it gives you like full granular control. So for certain cases where the optimizer is just not good enough, Huff is the right language for you. And it's very bare bones. It basically looks like EVM opcodes. Well, it is EVM opcodes, but it gives you a very nice harness around it so you can like build and layer macros in a very nice way. And it has very good testing support in frameworks like Foundry. So yeah, what's my second favorite language? I would have said Solidity, but I've been playing around with Faye a lot recently. And this isn't just because he said Huff, but we have a language that we use in Aztec called Noir, and Noir and Faye feel almost exactly the same to write, so I really enjoy that. And yeah, if you like writing Faye, then you'll also like writing Noir, so I like the two of them.
Forgot to get mine. I gotta plug this. My second favorite language is called Dazi. It's a Lisp for the EVM. Has compile time macros, super cool meta programming stuff, and it compiles to Viper, so it has all the Viper efficiencies after the initial stage of compilation.
Yeah, hell yeah, it's cool.
Sweet. So I'm JT Riley, or just Riley. So I'm representing Edge, which is this sort of experimental new language that I'm working on. It's very, very early in development, still working on specifications and things like that. But the primary goal for this is to basically experiment with the design space that hasn't really been explored by other languages yet, right? So this is things like, arbitrary data types can be deployed as contracts, things like type-checked opcodes, and much lower granularity in terms of the control that you can have without sacrificing some of those compile time checks that you get with higher level languages.
Great.
And second favorite language, I might have to go with Huff here. I've been around the Huff community for quite a while. And it's kind of unhinged, but there's a real pure beauty to it of being able to just have complete control over this machine.
Nice. So let's start with the EVM right away. So what are some changes in the EVM that you would like to see, and how does it improve your language or the ecosystem around it?
Yeah, I mean, something that I'm just generally not a huge fan of is precompiles. I know they're convenient and they make difficult problems easy to solve, but also they're just kind of a dead end in terms of analysis. You can't perform any sort of symbolic execution with them. mean, maybe there's some workarounds, but yeah, it's just difficult to work with, and I would rather see us solving difficult problems within EVM languages themselves, and then also have a strong enough virtual machine where you can execute this code without breaking the bank.
This might not be directly about what I would change about the EVM, but we've got all these layer twos that are slight variants and slightly different, and we do a lot of our testing assuming kind of mainnet semantics. So I think I'd like to see more standardization around like what the differences are, how to test around them, how to handle them appropriately, so that compilers can therefore like have better support for all these ecosystems that are so similar, but in very intricate ways, sometimes so different. And I think that's something that we don't test around enough.
Yeah, I've had the pleasure internally at Aztec to be able to like design a new VM. So I've kind of been able to look at the EVM and kind of pick and choose the things I like and look at like potential improvements and pick things from that which I think are useful. One is like static jumps in general. So like having the jump location be an operand of an opcode instead of it taking it from the stack. Like we're definitely going to do that. It makes program analysis a lot easier because you don't have to brute force a lot of code paths that can possibly come from your stack or whatever. You can just have this piece of code will go here, this piece of code will go here, and you can make a lot better safety guarantees around that. So yeah, we're definitely going to be doing that in Aztec, and I think it's like, is it EIP 4200 that's trying to do
The
that?
EOF suite.
Yeah, it's all EOF stuff. So yeah, long live EOF, I guess.
So can't say I'm fully on board with the OF, and I'll spare you guys like the 8-hour ramble about the pros and cons here, right? But I think there are a lot of things that EOF gets right. So one, structured bytecode, that's pretty cool. Static relative jumps, like you mentioned, being able to do this deploy time analysis, aka compile time analysis. Jump tables, because that's always fun. We're kind of hacking them into Huff right now, but they're not very efficient, and it's kind of annoying to use. So having something natively supported would be great. More multi-byte opcodes would be great. Like for example, like arbitrary like dupe and swap. It's kind of absurd that we have like 1,000 items that can fit on the stack and we can only reach 16 deep. Like it would be really nice to be able to reach further down the stack. Subroutines are really, really cool too. I think there's some like pretty cool stuff that we can do there. And there's just like a huge design space that can be explored. And so overall, like I'm leaning somewhat in favor of the EOF changes, but not fully, So.
Yeah, great answers. So going back to your own languages, you had a 30-second pitch of the language. What would be like one big feature that is coming to your language that you want to highlight to the audience?
Yeah, so one of our team members, Yoshi, has been working on a refactor of the front end, and we're calling it Phi v2 internally. So yeah, our type system has kind of been stagnant for the last 6 months or a year because he's been working on that. I've personally been focusing on like standard library stuff, tooling. When this refactor hits, we're going to have equivalent support with Rust in terms of generics, minus associated types, and plus higher kind of types. So that's very exciting. Another thing is that front end is implemented using Salsa 2022. So if anyone is familiar with the Rust compiler, Rust Analyzer being the newest version of the Rust, newest version of the Rust Analyzer, uses Salsa 2018. Did people get that? Hopefully, okay. Yeah, so we're basically getting ahead of the Rust compiler itself with the underlying software that's being used for the analysis, which is pretty cool.
There's two big ones in Viper. One has been a long time coming, but we're finally going to have modules. A lot of thought went into what exactly the right way to do that is. Thank you. And it's really exciting because one of the biggest complaints about Viper has been like, my contracts get really long, I want code sharing, et cetera, et cetera. There's a lot of things around like, what does it mean to import some code and how should we present that at a syntax level that I'm really happy with the interface that we've come up with and will be exciting to share very, very soon. And for the optimizers, we have a new IR that's you might have heard some talk about. It's really, really exciting stuff there. Completely new approach that lets us optimize stuff in ways that we never could before. And like we're seeing like 25% gas efficiency gains like on already really good gas performance. So it's really exciting.
Yeah, so I wish there was a lot more to be added to Huff, but it's kind of like towards its end. I would say like, oh, we can add
Already
types,
perfect.
but no, we're not adding types. What's a type? No idea. Yeah, well, there's a PR open at the minute that we're gonna try merge in soon, which is that you can actually pass macros in as arguments to macros, which allows you to do some more heinous stuff, which will be fun. But yeah, it's kind of static in the way it is. There's not much more to improve. Maybe tooling wise, like there's been a lot of attempts at like auto documenting your code to come through, so we kind of want something like that eventually. But yeah, not too much. Sorry, guys.
Yeah, so for Edge, there's like this really, really big feature that I'm looking forward to, and that's its existence, because it is very, very new. So you know, nothing to report there yet, but you know, stay tuned, TM.
All right. I think Sean got into the tooling part a bit, and I have a question about tooling, which is, what do you think about the state of tooling today, and how can tools better talk with compilers and vice versa?
Yeah, so hopefully this answers that question. I think in general, what I would like to see more of is these languages themselves being used to test your contracts, test whatever code you want to deploy, perform the deployment itself, and even interacting with these contracts when they're on chain. We shouldn't be using other languages to interact with these contracts on chain. We should be using the languages themselves.
I have the opposite opinion, actually. I think every time we interact with our contracts, it's from an external language. When you connect your front end, MetaMask doesn't speak Solidity, it speaks JavaScript, right? And I think if you trust the interface you have to the EVM, then you should trust its output, right? And tooling, I think, should actually follow that direction, where there's a lot of stuff about writing a unit test that has nothing to do with the EVM. At some point, you're just calling some function that exists in a contract, and you're going to validate that the output was what you expected. There are use cases where you might want to jump into the EVM and validate some more stuff there, but for the most part, I think like using a general purpose language not only makes solving some problems much easier, it lets you plug into a wide range of existing mature tooling. So in Python, if you're interacting with your contracts from Python, you can use SciPy, you can use NumPy, you can use all the rich data analysis tools that exist in the Python ecosystem, and I think we need to think more like how do we make our contracts and the data that they produce more accessible to the tools that exist across programming as a whole.
So my opinion here is like somewhere in the middle between the two. So the third option. I think unit testing and everything like that should be done in language. So like if I have a function and I want to validate its correctness for like some set of inputs, like I should be able to within the same file do that. Just like Rust does this nicely. Actually, almost all new languages, all new package managers have this built into it. And I think it's the right direction. Like Huff has it, not many people know about it, but you can annotate Huff functions as tests and then just write tests with pure opcodes and it will run it and give you a gas report and stuff like that, which is useful. I mean, Noir has it for doing unit tests, but then, I mean, there gets to a point where if you want to start doing stateful things, then maybe it's time to like move into a framework because you don't want to ship an entire execution environment with your language with that toolchain. Maybe it's not the right, well, maybe it is, maybe it's not the right thing to do. I mean, yeah, it's that. So I kind of sit on the edge, and I think you're completely right that like you do call contracts from some other place, like from your browser or from some other execution environment. So you do need to test those flows, and just having like unit tests or something like that is not enough. You need something stateful and something like user focused. I think so. That's where I sit. And in terms of like how can frameworks support other languages better. Right now you'll see like the current developer toolkit that most people pick is Foundry, and it has only support for Ethereum, and it doesn't really have support for other languages. Like we've just had to jerry-rig something using its FFI system to do so. So you can use Viper, you can use Huff, but you have to use like these, I mean, if you've looked into their implementations, like extreme collection of bash scripts or whatever to like do it. So something, I haven't looked into it too deeply, and I know I'm criticizing it, and I don't want to, I need to look into it a bit more, but I feel like something like Foundry could define a very simple interface, which is compile, and you can just give it whatever bindings to whatever compiler, and I feel like it shouldn't be too difficult to like add other languages and not just enshrine Solidity. So that's something I would like to push for. Yeah.
Yeah, agreed. So I think, you know, like you mentioned, like a sort of hybrid model is really good where maybe you want these like very small, you know, sort of internal tests that you can define within like the same module or the same library, right? Things like that's really useful. And then of course, you want to be able to interact with it externally as if a user would, and then also, through these like atomic actions, right? Like if you're testing for some kind of attack case, like the attack is probably happening through some like really complex like atomic action. And so yeah, on that front, I agree. Like a hybrid model is pretty good. In terms of like tooling more broadly, yeah, I think like for one, we really need like a lot more in terms of like diversity of like language support. And I think we actually have like a unique opportunity right now because a lot of stuff is being rewritten in Rust. There's like just this whole movement of like new tools that are popping up, and like once these are kind of solidified a bit, right? Like if we don't take into account the idea that like all of these other languages exist and there will be more in the future, then we're gonna miss out on like this really big opportunity to like really expand and explore like a broader space than just basically Solidity and then other language compilers hacked into Solidity, right? So yeah, and then I guess one more piece on the tooling here, right, is like some kind of package manager that's like not just Git submodules would be amazing. But that's a whole other like thing that I think is actually more on like compiler teams to make this decision of like how do we want to do this, right? Like we could go the Python route and just say like, yeah, good luck, have fun. Or like you could go the more like enshrined route where like, well, cargo is not really enshrined in Rust, but like it's very tightly coupled with this, right? Like you can tell that like there's thoughtfulness with this kind of thing. So I'd love to see that change in the future as well.
Amazing. So here is a question from Twitter, or it's called X now. This is from Brock. Is Yule a good enough IR? It looks like Faye supports Yule, but planning to change it to their own IR later. Edge also seems to be targeting Yule these days. What are some good characteristics of a cross-language IR? Sorry, do you want to explain what an IR is before answering the question?
Yeah, so it's a language that sits between the higher level language and the bytecode, and it assists with the translation. Yeah, I mean, I think like, okay, yeah, so we're going to switch over to this Sonatina backend at some point, but that's going to take some time. The reason why I mean, I could get into like some more stuff here. The thing with Yule is that like it's quite unconventional and it deviates from existing compiler backends like LLVM. So you don't get to leverage all of the research that's been done on optimization, things like that. So yeah, I mean, I think like a backend that is more in line with LLVM would be nice. So I mean, yeah, that's not really a characteristic, but it's just the general approach that we're taking there. Yeah.
I've never had to work with Yule directly too much, so I can't give too much of an informed opinion. I know there's some stuff missing, like around control flow, that makes it harder to optimize. And something that's really good about the new Viper IR is it follows kind of a more traditional approach and lets us apply a lot of like optimizations that are really like textbook optimizations that you learn in college compiler classes that because the IRs we've been using kind of looked weird, we couldn't necessarily apply, but now we're following something called strict single assignment, lets you handle code a little bit differently at the IR level and make some optimizations that you could make on other IRs much simpler to do, making the compiler easier to understand, keeping all your compiler passes simple. And I think that's what an IR is for, right? Like no one is going to realistically be writing IR. No one's going to see no one needs to see what it looks like, but the compiler needs to be able to understand it and optimize it. So I think that's what it should optimize for.
I can't talk too precisely about this topic either, but yeah, I think Yule itself probably needs a couple of higher level things built into it. Like it's very strict and there's not really much you can do around it. Like, yeah, I can just agree with what these guys have said. I can't add too much.
Yeah, so I think probably every compiler engineer that's like written some kind of IR has like had this thought of like, man, like I'd really like to be like the next Chris Latner, right? For those that don't know, Chris Latner is the guy that wrote LLVM, or like at least started it. And that's kind of like just the de facto like compiler tool chain for like most backend architectures, right? Doesn't work for the EVM. I think actually the Ethereum Classic community tried this a while back. I have no idea what happened with that though. But either way, like I think Yule is like a pretty solid IR. Like in terms of like what the plan is for Edge is like not to make a personal opinion on this, just kind of allow people to choose like their arbitrary backend, right? Because in a sense, like there's different levels to IRs that you can have, right? Like if you've ever dug into the Rust compiler, there's like 6 different IRs in this thing before the LLVM, right? And you can do this like sort of lowering system where you can do like optimization passes and all kinds of like really cool heuristics and checks and things like this, right? That are really nice. So yeah, I think like in general, like it would really be cool to see if like compilers could kind of target like multiple IRs through one way or another. But I think overall, Yule's pretty battle tested. The compilation is unbelievably slow sometimes, but that's just how it is. I imagine that gets better in time. The new Viper IR is pretty wild. Really looking forward to like playing with that some more, and really looking forward to checking out like Phase Sonatena as well. So I think it's gonna be pretty cool.
Yeah, I just wanted to say some things about Yule. So like back last year at DevConnect, I gave a talk about like how we built a compiler on top of Yule. And Yule was really good for just getting a compiler project off the ground because it has these higher level features that you'll find in a higher level language. So creating that transformation is much easier. And plus the code that you're generating can be understood, So like developing the compiler front end, it was easy to see what the output was and easy to understand it and easy to make changes.
It's a good insight. Here's another question from X, this time from Vex from Optimism. What are some other things that, let's say, other EVM languages are doing well? Maybe some features that you like, some other things that other compilers do well?
Yeah, so I mean, for all you guys, well, first, Solidity, you've done a great job of basically being like 99% of, the code that's deployed on chain. Yeah, Viper, it's great to hear that you're moving towards an IR that is, similar to LLVM. That's the direction that we're taking, and we're looking forward to catching up with you guys in that regard. Huff, you guys solve a very specific problem. These higher level languages, they generate code that oftentimes is doing nonsense. In situations where you have a very simple problem that you want to solve, if you have like some sort of bytecode that is going to be executed a lot, it solves that problem very well. That's a problem that us higher level language developers will probably won't solve for a long time, and like people will be using tools like Huff for a while. For Edge, it sounds like it's very, very early stages of development, but people love Rust, and I think a lot of people want those Rust-like features. There really aren't any other languages that compare to Rust out there, and we need more of them.
I think all the EVM languages are really cool. I think Dazi has macros, which is awesome. But more realistically, Solidity lets you pop down as low as you need to, which is something that Viper definitely does not. It's for philosophical reasons. We try to, those things belong in the compiler, not in your code, is kind of the philosophy you try to follow. And yeah, for someone who knows the compiler and can jump in there and like add this optimization that I need, that's great. But sometimes people are limited in that. So I think Solidity does a good job of exposing a sane way to incorporate some assembly and high-level optimizations into your contract if you know what you're doing. But that if you know what you're doing is really important there. But I think all languages are cool. It's awesome to see like different approaches to solving similar problems. I look forward to seeing what Edge does. I'm always amazed at what the wizards with Huff can pull off. Super cool. So I think, Faye, I unfortunately don't have enough experience with, but I really want to get to know better, and I think that Rust-like syntax is something people definitely want. So yeah, I think they're all doing things that different people want, and it'll be exciting to see what continues.
Yeah, I mean, got to piggyback and like also say we really do appreciate what Solidity does. It's never really had code gen issues that have been critical, which is brilliant. And it's a hard thing to do, like especially whenever you have so much value that's being secured by that language. I see why it's you want to spend more time on it being secure than like trying to squeeze out performance. But that's why other languages exist. Like, yeah, and I appreciate the innovation that's coming from the rest of the guys here is like pushing in their own lane towards like solving those problems while Solidity probably can't move that much. Yeah, little details and feel Faye I really like. Whenever you generate the bytecode in between the constructor code and the runtime code. There's a little FE between the two, which is nice. Nice details.
Wait, sorry. What's that?
I ran the tutorial the other day, and it's like there was a little like invalid opcode between the constructor code and the thingy code. I thought was really nice.
Sorry, I guess I just don't know what you're talking about.
We'll talk about it.
We'll catch up
talk about it
afterwards.
after.
I think we're gonna have to get blame that one.
Yeah.
It's probably something that Yule does.
Or maybe it's a Yule thing.
Yeah, I
I
mean,
thought it was a Faye thing.
It puts a Surex FE between
Yeah.
the constructor and the init code, and
then
also
there's
like
the
at the
theme.
end before the metadata too. But after the EOF, we can probably get rid of that, have proper data sections.
Keep it.
Maybe Fee can keep it.
Compliment has been redirected.
Sweet. So, anybody that kind of follows the content that I create, I'm usually like pretty critical of Solidity. It's kind of like a love-hate relationship in a way, right? Like I've written more Solidity code than probably any other language out there, and there's a reason for that, right? Like it takes you quite a long ways, and there's a lot of really cool and kind of unhinged stuff that you can do in the language. There's like this good blend of like, if you really want to like drop down and do something like strange, it is technically possible. Maybe even if you don't get the same checks that you would get. If you didn't do that in assembly, so it's a little bit of the best of both worlds you can get out of that, and obviously like huge respect for kind of pushing the envelope on a lot of this stuff. In terms of Phi, really like the generic system. Big fan of all that. Rust like syntax is pretty sweet. Type unions is something that I'm really looking forward to, and like pattern matching against them. I can't wait to see more of that. In the EVM, we can get some pretty solid designs that come out of that. I think. In terms of Viper. Love Viper to death. There's kind of a cap on like what I can do with it, but overall, I think it's like really nice how like you really have to go out of your way to do something stupid with it, which is really nice. It does a very good job of like protecting you and giving you kind of most of the tools that like you need in like day-to-day usage. In terms of Huff, of course, love it. It's like about as simple as it can get. Like writing like mnemonics or just straight bytecode. It's just like not like, no, I'm not doing that, right? But like Huff gives you like just enough that you can like really feasibly write some like low level, like high speed stuff.
I have a quick follow-up. You guys already hinted at this, but is access to inline assembly or something equivalent, is that a feature or a bug in a language?
I think it can be a nice feature if someone knows what they're doing. As of right now, that's like, so we have a EVM module in our standard library which gives you access to all of the EVM opcodes. So that's as close as we get to assembly. I think ideally, so we also have we have unsafe modes. We have an unsafe mode in Phi. We hope that at some point we can hide a lot of these EVM functions that we expose under totally safe abstractions with no overhead. So I mean, that's what we would like to have. But yeah, I mean, we'll come to that when we have our own Sonatina backend and we can actually consider adding assembly.
I would say it's a bug, but it's a useful bug. As a developer, when I'm writing my contract and I needed to do something, yes, it's great to be able to drop down and get exactly what I need done at a super fine-grained level of control. Exposing that to a wide audience of developers and saying build your industry on top of this, I think is a very dangerous thing to do. And I think anytime that you're writing assembly in your contract, it's a limitation of the compiler you're working with. I think even hardcore optimizers, might say like ideally one layer languages should be good enough where you don't need to do that. It can get optimized away by the compiler. That's the compiler's job. But I also think that, we're all here because we like to build and we build on the edge, and sometimes you just need to get some bytecode in the right place. In Viper, I've had to like literally add that to the compiler as a built-in when I've needed it, which of course not everyone's equipped to do. But overall, I still think that we're providing tools for people to create very powerful applications, and it's really important to make sure those tools push them in the right direction with the right patterns and make the right kind of safe code easy to write. And you can make your language super nice and complex and then depend on this escape hatch to assembly, and ideally you shouldn't need that escape hatch, right? Your super complex syntax should be efficient enough that you don't have to drop down. So yeah, I think it's a bug. It's something that we should try to push against. I think that no one likes to read assembly no one likes to write. Assembly and our languages should be good enough that we never have to. But it's a necessary evil sometimes.
I'm of the opposite opinion. I think it's a feature and it will stay. And like the reason behind that is quite a long one. It's like if you look at back in the day, resource constrained environments, that's when teams were the most writing everything by hand to try and optimize. And as compute gets cheaper and cheaper, then you can hand a lot of stuff to an optimizer, even if it's not that efficient, because you don't care anymore, because compute costs became trivial over time. We don't have that in EVM at all, and I don't think we ever will. So for anything that isn't like, well, assuming Ethereum will continue to be expensive, which it probably will for a long time. Yeah, so I think like for the most critical code paths, and even this is true in all zero knowledge code bases, you're gonna see, if you go into all of their elliptic curve operations, all of it is written in assembly still, and like that's utilizing LLVM at the top. Like so even code gen pipelines that have existed for a very long time and have a lot more resource sources focusing on them than like the people in this room, then like you still need to do it for very complex things. And I think that'll be true for any critical stuff. I mean, Seaport have had this vision where they've like, okay, our contracts are used enough that like the amount of money that we spend on developers who know this stuff and can secure this stuff is a lot less than like the perpetuity of all the gas fees for what we've saved over time will end up being. So it's a worthy trade-off. And for the most critical things, I mean, we've got Phil at the front here, who's working on Meth, which is like a hyper-optimized WETH implementation in Huff. That like, I know there's going to be it's going to be a pain to integrate that with the rest of the ecosystem, but I think it's a worthy thing to do, considering that WETH will be there forever. That like the savings that you will get from that will probably, in the long run, will probably outweigh the pain of switching. That's a bit of a hot take, but yeah, that's how I feel about it all. And it's not a unique thing to EVM languages. It needs to exist in all languages. If what you're doing is like slightly off the beaten path, then you will need that.
Yeah, so you know, as an inline assembly enjoyer, you know, I think while inline assembly should always be enabled, right? Because there comes a point at which like most developers kind of want to take the gloves off and you know just kind of go crazy on something. I think for the general use case, you can consider this a sort of failure of the compiler because inline assembly happens for one of two reasons generally. One of those is there's something that you want to do in the language that's not enabled in the language. So maybe like, you know, maybe you want to do something with like a return data pointer, right? But like that doesn't exist in like any language today, and so maybe you want to do something weird with that, right? But like that should be, yeah, that should be like relatively trivial to implement in the language, or the language should have some kind of extensibility that enables this, right? The other case is context. Like you have some context about some block of code, something that needs to be executed, and you cannot give that to the compiler, right? For most cases, I think like you should be able to give, you know, pretty much all the context that you need, and then in a sense like having these sort of like functions that kind of wrap opcodes and they're like type checked and things like this, like that's not really inline assembly, right? Like it's very close, like it's very low level control, but at least you get some kind of smoke check on like what's actually happening there. Whereas, yeah, you know, like there's always going to be like the Phylogys and the Vectorizes of the world, right, that want to go and you know do some like wild stack scheduling abuse or something that like you just like there's no way you can represent this in a high level language. So like definitely for those edge cases, I think it's valuable. But yeah, in general, I think it should be avoidable for almost every use case.
Great. So let's take some questions from the audience. Any questions?
Hi. So, thank you very much. Excellent panel. Reentrancy is one of the most common vulnerabilities that exist here. And Solidity is infamous for it. Viper solves it on a different level, and I guess that all these different programming languages solve it on their own. But my question here is, do you believe that the security community should be more involved on the language design? for everyone?
Absolutely, yeah. I think security experts and compiler experts are very different groups of people, and the more we bring those two together, the better. I think we have incredibly talented auditors, and it would be awesome if they took a crack at auditing a compiler, understanding how the compiler works, making it less of a black box. The more education we had around that, the better, I think. Yeah, Viper had this big issue around it, and a big part is like there's a very small group of people that work on this software, and the more we can grow that and the more security aware people we can bring into that, of course, the better that'll be.
Yeah, so I think while like reentrancy is like this big like infamous like vulnerability that just happens like all the time, and it's kind of wild how much it happens. I think like especially with the inclusion of transient storage, here soon, fingers crossed, please. We're actually going to have like a pretty broad design space of how we can like do these reentrancy checks. And even if so, I know like there was a proposal around the Viper compiler to actually just have reentrancy like checks by default, and you have to explicitly go out of your way to allow it. I think that's a really cool, design decision. I think like obviously there's like pros and cons to each of these, right? But I think in general, it would be really nice if there was some way to have. Okay, backing up for a second. Reentrancy guards, like, you can kind of have like more or less two of them, like two kind of designs right now. One is like the contract level, and we can kind of call this a mutex, right? Like this is ensuring that like only one like thread or one execution context, has access to this thing at a time. So there's like the contract level, right, which is like the very basic like Open Zeppelin, like lock this thing, unlock this thing, right? And you can apply that to every function, and it applies to everything, right? The Viper model is kind of more around like, okay, we can have these arbitrary keys, and so like theoretically you could just have, which I guess you could probably also do this with Solidity, but the way that kind of Viper does this out of the box is you get this like function level mutex, right? You can have mutexes over individual functions. And then with transient storage, because we have like this whole entire like 256-bit like map data structure that we can play with now, it would be really cool to see even like variable level reentrancy guards, right? Where you can say like this deposit mapping, for example, should have a mutex over it, such that like no code, like any code path that tries to touch this while the lock is active just throws, right? Like so, I think it's like this huge design space that's about to open up, and I'm really really excited to see where that goes. And I hope that either these things are enshrined in the languages or they're like sort of defined in these like really popular libraries or standard libraries to get some pretty wild use out of that.
Go for it.
We are at a Solidity Summit here, and the panel is called the State of EVM Languages. But do you think there's space for alternative VM or alternative VM languages, such as Move, or maybe even some sort of crossover of these two spaces?
Yeah, I think so. There's a couple different VM architectures going around right now. Each one kind of optimizing for their own things, right? Like Starkware's VM is kind of optimizing for like Stark proof sizes. You have like the Move VM, which is like really has these like really cool like safety features. There's like Fuel VM, for example, that has this like hybrid like UTXO like state model, and like there's like a ton of different things happening in terms of experimentation. And I think this is like really really important because I think over time, probably the best thing that can happen to Ethereum, like L1 Ethereum's EVM over time, is that this actually ossifies within the next couple of hard forks, right? Such that like this should not change anymore. Like immutable code on a mutable machine is like a wild idea that like should not be a thing, right? So like ideally, L1 Ethereum kind of ossifies over time, and then we see more experimentation on L2s, where like necessarily there isn't like in a sense like not as much to lose, especially in the early days of like, okay, we can really try completely new architectures, new paradigms and things like that. So I think there's a huge design space for that, and it's actually really underexplored, I think.
Yeah, what he said.
I think alternative VMs are awesome, but bringing it back to like the languages, I think that our languages are domain-specific languages, and that domain is the EVM, and there's a lot of EVM-specific stuff that you need to be aware of when writing a smart contract. So while I love alternative VMs, I think they're all super cool, and they all have their own interesting features. Sometimes people talk about, what if you compiled Solidity or Viper or something else to this other VM, and I think that maybe if it's similar enough, but now you have two similar but slightly different things, and that's kind of the most dangerous kind of tool to deal with, because that makes it way easier to make a mistake. So super huge fan of alternate VMs, but I think the language level at least should probably stay separate, at least for the level at which we're writing contracts right now in terms of like low level versus high level. I don't think we're high level enough to abstract away the VM specific stuff yet.
I mean, for fee, at some point in the distant future, we would like to target multiple backends via Sonatina. But that's all very far off and theoretical, but it's something that we keep in mind as we design the language and the intermediate representations.
David, go for it.
I'm just wondering, like, what you think about introducing some of the more kind of advanced safety features into EVM languages, like maybe refinement types or dependent types, or like linearity, these kind of things that you see in like theorem provers or kind of modern functional languages.
So, sorry, could you repeat the last bit there?
Like the kind of things you would see in like theorem provers or like kind of modern functional languages, like really kind of high-level formal safety features, if that's something that we should be looking into for EVM languages.
Yeah, I mean, something that I've done some prototyping on with using K-framework, but I'm exploring other options is symbolic testing. That's a really great way to get formal methods in the hands of developers, you know, because there's basically no overhead to understanding that compared to concrete tests.
Yeah, I think when it comes to these functional languages and languages that you have like this like calculus of constructions and like these really nice like these really nice like proof systems and type systems. Like I think in retrospect, like in like some arbitrary point in the future, I think we're all going to be using these not just for smart contracts but just in general, and it's going to be like very obvious in retrospect. Like, oh my God, why do we used to write write all these like programs and all these like wild languages and like get hacked all the time, right? Like we could have these like these like provable programs, right? That are like very, very hard to like break, and maybe in some cases are just impossible to break. I think, yeah, long term that's absolutely something that we need to have. But I think also like these wheels turn very slowly. Like it took a very long time for us to even have like subtyping and like parametric polymorphism really like at scale, right? So yeah, I think in time it definitely comes. It's going to take quite a while, I think, but once it does, I really look forward to that world.
I see more people want to ask questions, but I was told to wrap up. Maybe you could continue having the conversations off the stage, but I want to conclude this by saying, thank you very much for joining the panel. It was very enjoyable, and thanks for the audience as well.